first session of Java. So throughout the session of Java, we will have the important features of Java. We will see how do we code in Java, what are the various variables, data types, and what are the methods in Java. Then we will also understand the object-oriented concepts, which is one of the most important concepts of Java. We will also see exception handling, and we will go through all the important aspects that are of Java. And in this particular session, we will have a brief introduction about Java. We will see what Java is and what has been a brief history about Java, what are the features of Java, what makes Java different from other languages, and what is the difference between Java and C++. Since we know that both Java and C++ are an object-oriented language, so what is the difference between the two? So we will see these things in this particular session. So first, let's start with the question, what is Java? So I can say that Java is a programming language and a platform. So Java is a high level, secured and object-oriented programming language. So we will see what secured and object-oriented is. So as of now, understand that Java is a programming language as well as a platform. So why am I saying Java is a platform? Is that what is a platform? Platform is anything in which you can run a program. So it is a whole environment in which you can run a program is a platform. So Java gives you a runtime environment, and it is also has a set of APIs which allows you to run your program. So Java has a runtime environment which is known as JRE, Java Runtime Environment, and it has APIs or libraries. So we have this JRE and API with the help of which we can run any Java program. We will see what JRE is. As of now, try to understand that Java is a programming language and a platform. So what are the applications of Java? Talking about the applications of Java, Java has its application in desktop applications. So we can build desktop apps using Java. We can build a media player. PDF reader. So there are various applications that can be built using Java. We can build an antivirus. So Java is a very secure language. So we will see why is Java a secure language. So as of now, trying to understand that Java has these applications. It is used for building desktop applications. It is used for building web apps. It is used for building enterprise applications such as banking apps. It is used for building mobile applications, games. It also has its application in robotics. So as of now, we have seen that these are the applications of Java. So what happens is that Java has 4 editions. It has a different software edition for building web apps or different set of libraries for building web apps, and it has different edition for building mobile applications. So let's see what are the 4 editions of a Java. So there are 4 editions of Java. First being Java Standard Edition. These are just a set of information that I'm giving you about Java. So this Java Standard Edition is the core Java programming platform. And it includes core Java programming topics or core topics like inheritance. Actually, it comes under OOPS only. Exceptions, inner classes, etc. So these are the core features of or you can say that These are the core topics of Java, and this comes under Java Standard Edition. So you can say that Java Standard Edition is the core of any other edition. So all the other editions are built on this particular Standard Edition. So next we have Java Enterprise Edition. So Java Enterprise Edition is used to build applications for enterprises. As I said that enterprise application like banking apps are built using Java Enterprise Edition, and this is built on the top of Java Standard Edition. And in this session we are going to discuss topics that come under Java Standard Edition. So Java Enterprise Edition, another edition of Java, it is also known as Java EE, and it is used to build enterprise applications as well as web applications, and as I said, it is built on the top of Java Standard Edition. It has topics like JSP, servlets, web services, etc. Next we have Java Micro Edition or Java ME. This is used for building mobile apps. Then last we have Java FX. It is used for building rich internet apps. These three editions are not of concern as of now for us. In this session we are going to talk about Java Standard Edition and these concepts. So let's try to know a bit about the history of Java. So Java was developed in year 1995 by James Gosling, and there has been several editions till then. So what happens is that if you build any software or any thing, you keep on revising the edition, you keep on adding the new features, and you keep on revising the edition. So there has been many editions, and the latest one being Java SE 10. This is the latest stable Java release. Now let's try to know more about Java by going through the 12 features of Java. These are also known as Java buzzwords. So as we go through these 12 features of Java or 12 buzzwords of Java, we will understand more about Java, that what Java is and what are the features of Java and how strong Java is compared to other programming languages. So now let's go through the important features of Java. The very first feature of Java is it is simple. Now why is it simple? So first reason Java is simple is that Java is built very closely with the syntax of C++. So if you know C++, you can easily understand Java. So it is built closely with C++. And Java has removed all the confusing features that we have in C as well as C++. So in C and C++ we have pointers, which we know is a very confusing and very complicated concept in case if you don't understand it properly. So we don't have the concept of pointers in Java. It has been removed from Java. So to make it simple, we don't have pointers in Java. We don't have the concept of operator overloading. In case you know C++, you must be knowing that we have this operator overloading in C++. So these are the features which are complicated and are not very often in use. Like operator overloading, we know that it's a complicated concept and not often in use. Then we have unions, structures. So these features have been removed from Java, which makes Java a comparatively simpler language. Next, we have automatic garbage collection. Automatic garbage collection is one of the very important features of Java. So what happens is that we know that in C as well as C++, whenever we get some memory, so let's say in C we get a memory using malloc, so we have to make sure that whenever we are done with using that memory, or let's say I allocate some memory to a particular variable, so whenever I'm done with using that memory, I have to manually release that memory. And same is the case with C++. So we have destructors there in which we do the task of releasing the memories. And in case I forget to release the memory, the user who has written the program forgets to release the memory, we will run out of memory, and whenever we try to get a new memory, we will get out of memory error. But in case of Java, we have automatic garbage collection. So what happens in automatic garbage collection is Java automatically releases the memory which is not in use. We will talk a bit more on automatic garbage collection later on. So the next feature of Java is object oriented. So what happens in object oriented is that any programming language that is object oriented is that it moves around objects. The main focus is on objects. So it is built of objects and classes. So what is an object? Consider a scenario, a carpenter wants to build a table or a stool. If a carpenter wants to build a stool, then that stool is an object. In case of Java or in case of object-oriented programming language, the focus of the carpenter is on the stool, which is an object there. But in case of C, the focus is on the tools and the methods that are being used to build that tool. So in object oriented, the whole application is made out of objects, and everything in Java is an object, and every object has a data and behavior. So data can be thought of as variables that an object will have, and behavior can be thought of as a method. So data is like the feature, that what feature or what variables a particular object is having, and method is like the function, like a particular object is having what kind of function. And classes is just a blueprint of objects. It's like object is something that actually exists, classes don't exist. Objects are instance of classes. We'll talk a lot more about objects and classes when we go on to discuss object-oriented concepts. As of now, try to understand that Java is an object-oriented language in which everything is based on objects. And this usage of objects and classes simplifies the software development, and it simulates real world very well. So the use of objects simplifies development, software development, and it simulates real world. There are the 6 basic concepts of object-oriented programming. 2, as we have seen, is objects, classes, then we have inheritance. We will talk about all of them when we discuss object-oriented concepts in detail. Then we have encapsulation, abstraction, and polymorphism. Now, talking about the another feature of Java, Java is platform independent. This again could be an interview question. There are many times this question is asked, that why is it said that Java is platform independent? So what happens in Java is, so let's say what happens in C or C++. So whenever you have any program, let's say you have a program, and whenever you compile this program, so this program gets compiled to a machine executable code. So let's say I'm running my program on Windows. So when I compile my program on Windows, so my C program gets converted into a code that can be run on a Windows platform. For that matter, if I'm running it on a Linux platform, then after I compile my C code, it gets compiled to a machine executable code that can run in Linux code. It's not possible that I run the Windows machine executable code to Linux machine executable code. Both are different. So this is the case with C and C++. The code gets compiled to a machine executable code which can be run on that particular machine only. What happens in Java is, let's say you have a program. So whenever we save a program, Java program, we save it using .java. So let's say I have a program .java. So what happens when you compile a Java program? It gets converted to a bytecode. This bytecode can be taken and run in whichever machine you want. It can be run in Windows machine, Linux machine, or Macintosh. You can run it on any machine. It's just that that particular machine needs to have JDK installed and needs to have the JVM. So we will discuss again JDK and JVM. What is that? As of now, try to understand that Java is platform independent because when you compile a Java program, it gets converted to a bytecode, and this bytecode is not machine dependent code. This bytecode can run in any machine, be it Windows, Linux, or Macintosh. It's just that that particular machine needs to have JVM. That's why I say that it is platform independent. Next very important feature of Java is that it is secured. Now, why Java is secured? First reason why Java is secured is that Java, before I continue further, let me tell you that each and important feature of Java, you can get an interview question or an objective question from each of the features of this Java. That's why we are discussing these features. So make sure you understand all of these features. So now the question is, we say that Java is a secure language. So why Java is secured compared to other languages? First is that we don't have pointers in Java. So we know that using pointers, we can access the memory location of a particular variable. And in case we have the memory location, we can make whatever changes. Let's say I am someone who wants to make changes in that particular memory location, and that change, let's say I want to put a virus in that particular location. So we know that in case I have memory location with me, I can make changes in that particular memory location, which can be harmful. So what happens that Java is a secure language. We don't have the concept of pointers. So you cannot directly access the particular location where a particular variable or particular data is stored. So Java is comparatively secured. Next point is, why Java is secure? Because Java runs inside Java program runs inside Java virtual machine. Okay, now let's try to see how a C++ program is run and how a Java program is run. So we have, let's say this is a C program or C++ program, and this is the runtime environment of our operating system, OS. So this C++ runs in the runtime environment of OS. Now talking about Java, what happens that this is a Java program. Java runs inside the sandbox of JVM or Java virtual machine, and then we have operating system. So there is a sandbox between operating system and the Java program. Hence it is more secure compared to other programming languages, and this is the reason why Java is used to build many antivirus systems. So Java is a virus-free system. It is difficult to put a virus, or it is difficult to hack a system built using Java. Also, Java has a bytecode verifier. So before a bytecode is run in a system, Java has a bytecode verifier that checks that whether there is any illegal code that has to be removed or that is not supposed to be executed. Next, we also have security manager. It determines whether, let's say, someone is trying to access the reading and writing on a disk illegally. So this security manager actually checks that whether a particular request has the authentication or has the access to read or write to the particular local disk. So before accessing any resource, this security manager keeps a check. So Java is a very secure language. Next we have Java is robust. Now what is robust? Robust means strong. And why do we say Java is a strong language? First, because it has strong memory management. Next, again, since we don't use pointers in Java, it is not possible to overwrite a particular memory. So overwriting a memory or corrupting a data is not possible in case of Java since we don't have pointers. Next, we have Java compilers are comparatively better compared to other languages because many of the errors that are detected by other language during runtime is detected by Java compiler during compile time only. So next we have exception handling mechanism in Java, which makes it a strong language. We will talk about exception handling in details. Next, Java is architecture neutral. Why is Java architecture neutral? Because in other languages, let's say in C, if we have an integer, it will be 2 byte in 32-bit operating system and it will be having 4 bytes in 64-bit operating system. So the size of a particular data type depends upon the size of the architecture of the system. But in case of Java, the size of the data type remains same irrespective of the architecture that we have. So the size of integer will be 4 bytes in both 32 and 64 bits of operating system. Talking about the next feature, next we have Java is a portable language. Again, this comes from platform independent. So what happens in the case is that in case you have compiled a C language on a particular machine, you have to make sure that it runs on that particular machine only. But in case of Java, once you have compiled a particular Java code, you get a .class file, which is a bytecode. It converts into a bytecode and you can take this bytecode and run on any other machine. So you can port this code from one machine to another. Hence, I say that Java is a portable code. Next, we have Java has high performance. Java has inbuilt just-in-time compilers. This is just So what these kind of compilers do? So this just-in-time compiler is built inside JVM. We will see more about just-in-time compilers when we talk about JVM. As of now, trying to understand that just-in-time compilers, how they increase the performance is they take the code, similar code, and they optimize it such that there is speed in execution. Or for that matter, let's say we have a code that is run very frequently. So the just-in-time compiler will optimize that code or compile that code and optimize it such that it enhances the speed. Next, we have distributed. Java is a distributed language. So Java is intended to be used in networked and distributed environments. So Java has library of routines for dealing with TCP/IP protocols like HTTP and FTP. Using Java, you can access any file that is kept on other machine using a URL such that you are accessing that particular file in your own machine. So nowadays, this thing of accessing file that is there in another machine is a very obvious concept, or it is taken for granted. But back in 1995, this was a tedious task to do, or it was a major undertaking. So Java enhances this thing. Next, Java is multi-threaded. What happens in a process can have multiple threads. So when a process has multiple threads, it can do many tasks. So let's say we have a web page. So it may happen that there is a web page which has forms and some images. So we can have a thread for downloading the forms, or we can have a thread for downloading the images, or we can have a thread for interacting with the user when the user is filling the form. So we can build several threads, and each thread can do a particular task of a particular application. So this web page is an application, and it has a form, it has images. So it may happen that some error occurred by downloading the images. Still the page will be responsive since this thread is blocked, but the thread that was handling this particular form hasn't been blocked. Java supports libraries to create and manage these threads. So we say that Java has a feature of multi-threading. Next, Java is a dynamic language. So what happens is that in Java you have several classes. Let's say you have an application that has several classes. So what happens in case of Java is when you're running that application, all the classes are not loaded at once. It's not necessary that if there are 5 classes, then all the 5 classes will be loaded before the application starts running. So it may happen that the classes are loaded dynamically. It may happen that okay, there's a particular dot class file and I don't need that class file right now. So I will load that class file only when I need it, only when there's a need to load that class file. So it is dynamic. The loading of class files is dynamic. So it is loaded on demand. The last one is Java is an interpreted language. So what happens is after you have a bytecode in hand and you want to run this bytecode. So this bytecode is run using an interpreter. Okay, so this comes up with a question that what is the difference between compiler and interpreter. So what happens in compiler is that in case you have a 10 lines of code, this compiler compiles the whole 10 lines of code and it gives you an error at the end. But what happens in interpreter is that interpreter executes the code line by line, and whenever there is an error in the line, in a particular line, it throws the error or it shows the error from there only. So what happens is that in Java, first the Java file is compiled to a dot class file, and after that dot class file is interpreted or the bytecode is executed using an interpreter. So these are the 12 important features of the Java. So we can see that Java is a very strong language. Java is a object-oriented language. It has high performance, it has high security, it is dynamic, it is interpreted, it has multi-threading. So these are the important features of Java. Now let's proceed further with a small program of Java. Hello everyone, welcome to the